Hello, this video will be the first video of a playlist that will cover all content associated with a standard pre-AP chemistry course, along with the content covered in the New York State Regents curriculum for Regents chemistry. In order to get the most educational value out of this video, I would advise taking notes along with it. So this is Unit 1, Math Concepts in Chemistry. The first lesson in this unit is applying the percent error formula in chemistry. The formula is percent error equals measured value minus accepted value divided by the accepted value multiplied by 100. The measured value refers to the experimentally determined quantitative value. So if you were measuring the density of water and you were dividing the mass by volume and your resultant was 0.97 grams per centimeters cubed, that would be the measured value. The accepted value is the scientifically noted numerical value, which in this case for the density of water is 1 gram per cubic centimeter. So if you were going to apply the percent error formula to this context, you would do 0.97 minus 1 divided by 1 multiplied by 100. Here are some practice problems that relate to what we just gone over. In the first problem, we have copper sulfate, a hydrated copper sulfate. Now, if the determined or measured value is 40% or the accepted value is 36%, the percent error would be the measured value minus the accepted value all over the accepted value multiplied by 100, which in this case would be 40 minus 36 divided by 36 times 100. And if you did that computation, you would get C, or 11% error. In the second one, you can try by yourself and apply the same calculation as we just did. Lesson 2, Learning and Applying Rules of Significant Figures. If a numerical value has a decimal point, when counting the number of significant figures in a numerical value, you start from the left and count all digits after the first non-zero digit. So if we were going to find the number of significant figures in 3,434.24040, we would start from the left and we would count all digits after the first non-zero digit, which in this case will be this 3. So this number will have 9 significant figures. A way to remember this is the Atlantic Pacific rule, which states if the decimal is present, then you will think of the Pacific Ocean, which is on the left side of the United States, and you would count going left to right after the first non-zero digit. If the decimal is absent, then you will think of the Atlantic side of the United States, which means you would start from the right and count to the left after the first non-zero digit. Now, we already gone over this, but if a numerical value does not have a decimal point, you're going to think of the Atlantic Ocean and start from the right side and count from right to left after the first non-zero digit. So to find the number of significant figures in 20,200, we count starting from the right after the first non-zero digit, which in this case would be this 2. So there would be 3 significant figures. Adding and subtracting significant figures. When adding or subtracting 2 or more numerical values, the resultant should go to the decimal place of the added/subtracted number with the least decimal places. So if we were going to compute the sum of 33.323 plus 232.2 plus 444.343. In order to do this, the answer should have as many decimal places as the number with the least. In this case, this would be 232.2, since this has one decimal place, one digit after the decimal. So if we were to compute this, we would use a calculator, which would be 709.866. So since we can only have one decimal place, the answer would be 709.9 when applying the significant figures rules. Now, in this case, we do not consider the significant figures. We only consider the amount of digits after the decimal place. Now, when multiplying or dividing with significant figures, the answer will have as many significant figures as the numerical value with the least number of significant figures that we multiplied or divided. So if we were going to compute the product of 33,459.3232 times 22.34 using correct significant figures, the answer would have four significant figures, because this 22.34 has four significant figures, where this number has 9, and we go to the number that we're multiplying with the least number, so it would be 4. So the answer to this would be 747,481.28. Now we can only have four significant figures. So the answer would just simply be 747,500, so that it only has four significant figures. So to recap, the difference in terms of significant figures between adding and subtracting and multiplying and dividing values is that when you're adding or subtracting, the number should have as many decimal digits after the decimal place as the number that you're adding or subtracting with the least number of digits after the decimal place. Now, when multiplying or dividing values, the answer, either the product or the quotient, will have as many significant figures as the number that you multiplied or divided with the least number of significant figures. I hope that made sense. So here are some practice multiple choice that are in resemblance of the pre-AP chemistry curriculum. So number 3, the number with four significant figures would be 1003, because you start, since the decimal place is absent, you start from the right and you count going from right to left. So it would be 4. Now A, since the decimal place is present, you start from the left and count after the first non-zero digit. In this case, it would have two significant figures. With B, the same idea would apply, but it has three significant figures, not the four that we're looking for. And in D, since the decimal place is absent, you start counting from right to left after the first non-zero digit. But since the ones place is a 0, it would only have three significant figures. Question 4 and 5 you can try by yourself. Question 3, learning effective implementation of the density equation. This equation will be provided on the Regents chemistry reference sheet. And if you're not taking the Regents chemistry exam and instead a different pre-AP chemistry curriculum, you will have to consult with your administrator on whether this equation is given or not given to you. Nonetheless, the unit for mass in chemistry is always grams, and the unit for length in chemistry is always centimeters. Subsequently, the unit for volume in chemistry is always cubic centimeters. Since density, as we see here, is equal to mass divided by volume, subsequently the unit for density is always grams per cubic centimeter, since we're doing grams divided by centimeters cubed. Density from a qualitative perspective is the amount of mass of matter per a volume. The density of a particular substance is always the same no matter what the mass or volume of that substance is. If we had a gold bar with a density of 19.32 grams per centimeters of cubed, and we cut that gold bar in half, the density would still be 19.32 grams per centimeters cubed, because when we cut the gold bar in half, the mass will be halved, but the volume will also be halved. So when we do the computation, the density will still be the same. If the density is greater than the density of the solvent, or if it's water, which has a density of 1.0 grams per centimeters cubed, then the object will sink. If less than the density of the solvent, or in this case water, if it's less than 1.0 grams per centimeters cubed, then the object will float in that solvent. That's it for Unit 1 of PreAP Chemistry. I would advise watching this video over again to effectively learn everything that was facilitated in it. Otherwise, I hope you have a good day.